We're Artyom and Slava from Checkpoint Research mobile team. What's happened to our slides?
Yeah.
All right.
Okay.
Anyway, our daily job is to find new ways into your mobile devices. So today we're going to talk about one such way that we found. And it's going to be through... Oh, that's a Windows update. How exciting.
No. No.
Yeah, it's going to be through SMS. So everybody knows SMS. It's one of the oldest mobile technologies, still in use. It's ironic that old school hacks such as fake SMS messages remain relevant even now in 2019. And with the hack that we're going to talk about, any attacker with a very cheap USB modem dongle can attack any phone across the world. And with just one SMS, he can intercept somebody's mobile traffic or steal his private information or possibly even set his browser homepage to his own site. And our estimate is that almost half of all smartphones are currently susceptible to this kind of attack. And this is because it's not a particular vulnerability in software or in hardware of these devices, but rather a straightforward implementation of a rather old specification which just was not designed with security in mind. So we start from the technical background. Our SMS is not just a plain text message, it's a client provisioning message. So start by describing the client provisioning technology. This is what the mobile network operators use to supply new settings to your phones when, for example, you switch it on for the first time on a new network, such as a conference abroad, like here. But also enterprises can use this technology, for example, to distribute their corporate email server address to their employees. And these settings take form of special SMS compliant with the specification defined by Open Mobile Alliance. This is a standards body which basically defines all the standards for the mobile industry, much like the IETF does for the internet. So it consists of members representing the equipment manufacturing companies, software developing companies, mobile network operators. Membership changes from year to year, and the companies which are on the board of directors this time around are shown on the slide. Curiously, it doesn't include any software companies this time around, but for many years it had included representatives from Microsoft and Converse. So what HOMA does is it writes specifications, much like IETF releases their own RFCs, which are identified with just serial numbers. Specifications by the Open Mobile Alliance have more structured hierarchical names, which also include a version number and a release date and a revision letter. So the specifications which are relevant for client provisioning are shown on this slide. And you can see that all of them date from quite a few years ago. The oldest one corresponding to the session protocol that dates back to 2002. And the specifications from may cover all layers of mobile communications, from the bits and bytes inside an SMS all the way to the general architecture of mobile communications. So we come into the specification, the SMS, which is dedicates all the protocol. When transmitted, it physically takes form of one or several protocol data units, or PDUs for short. But logically, it employs a full four-layer stack of protocols, much like the TCP/IP four-layer stack, except that all the protocols are completely different and unrelated to internet protocols. So at the lowest level, which is called bare layer, we have the short message transfer protocol, or SM-TP for short, to distinguish it from SMTP, which is for email. And its header specifies the recipient phone number, and it's curious that it allows not specifying the origin phone number. This is going to come handy to us if you want to impersonate somebody else. Then the transport layer implemented in wireless datagram protocol, or WDP, specifies the source and destination port numbers, which for client provision are hard-coded to the values shown on the slide. That's 2948 and 9200. the session layer handles authentication of a message. And then at the top application layer, we have the payload, which for a simple text message would be just plain text in a specific encoding, or it can be a picture or a voicemail indicator, which is what you get when your phone tells you that you have new voicemail. Or for client provision, it can be an XML document encoded in a dense binary format called WAP binary XML. So this is an example of what a client provisioning document could look like in source text format. So it has all the settings highlighted on this slide. That's the display name, access point name. That's what the receiving user would see. Also the network type that the settings apply to. And the WAP proxy details. That's where all his mobile traffic is going to be routed through. The settings document can also include other vendor-specific extensions. For example, it can specify email server or a directory synchronization server to know where to send his contacts and scheduled meetings to, or even browser homepage. So when the settings document is transmitted, it takes form of these two PDUs, because one PDU's user data is limited to 140 bytes, so we have to chunk it. And you can see that each PDU includes its own headers for the first two layers. Then the session header is entirely inside the first PDU, and the bulk of the PDUs is taken by the yellow-colored payload. So that's the binary and not human-readable representation of the same XML document, but you can notice the proxy IP number and port number as the plain text ASCII strings. It's basically the only detail you can recognize in the binary format. And yeah, all that attacker needs to supply his settings to your phone is to stream this 225 bytes through a USB modem, and then it becomes a SMS message.
Okay. So far, so good, but what about security? How does SMS protocol ensure that only your mobile network operator can provision in your mobile phone, but your colleagues cannot play prank on you in this way? So, first of all, let's take a look at specification. More important that Open Mobile Alliance specification, there is very little attention to security. More important, the security is defined to be optional. As you can see in the provisioning context specification, it contains the exact sentence which we show here. The connectivity media may contain security information. So it's may, it's not must, should, okay. And the second point, that if security information is presented, it relies on IMSI number of the recipient. The IMSI must be used as a network specified shared secret. What is it IMSI number, and why it's not really a good idea to use IMSI for any authentication? We will show later in this talk. So authentication is optional, but when present, it's dealt within the session level header. Here you see it dissected. It specifies the content type, this one, allowing security checks. After that, the second field here is a security method, network pin, which relies on IMSI number. Other options such as user pin also available. And the last field is in this session level header is message authentication code of payload. You can see message authentication code as hex ASCII string here. Actually, message authentication code is just SHA-1 hash of IMSI XORed with data. This means that anyone who wants to generate a message authentication code from IMSI just need to use a standard OpenSSL tool or any other cryptographic libraries to do this. As was mentioned, international mobile subscriber identity, or simply IMSI number, could be used as a key for client provisioning. And once we have victims IMSI, we can impersonate a genuine client provision message. But problem here is that IMSI, it's not really confidential. It's like IP address in TCP/IP protocol, which is not public advertised, but it needs to be widely known for mobile routing to work. And there are a lot of ways to extract, to find IMSI number of the target mobile phone. For example, any Android mobile application can query this IMSI number from the phone and transmit it to an attacker. Or any employee of any mobile network operator can disclose IMSI number. Or cheap fake BTS base transmitting station can sniff IMSI out of the air. And at last, each one of you can find its IMSI number just looking at its on your SIM card. For example, in this picture, you can see that IMSI number was printed on AT&T SIM cards. Stealing IMSI number with Android application doesn't require something special. Android provides framework, public functions. Actually, it's a get subscriber ID method of telephony manager, which returns IMSI. This method requires read phone state Android permission, but we have checked our records and find that over than a third of all mobile applications released in the last 3 years already have this permission, and it would not raise any suspicion. Any one of you with Android phones are sure to have a handful of installed mobile applications which already have access to IMSI number and can do whatever they want with it. So, how exactly do we perform this attack? We have simple USB dongle, and we need this SIM card. We just need to connect it to our laptop or PC, and we're using a simple Python script to put together the message bits for us. And less sophisticated hackers can use Now SMS or any other freely available software tool in internet. And for example, in this screenshot, you can see that screenshot of Now SMS tool. All just you need to do is to fill several fields in web interface of this tool and to press send a message button to send a provisioning to any mobile phone in the world. So, how demanding are the smartphone vendors in validating of client provisioning messages? We discovered that Samsung took it literally that authentication is optional, and any Samsung mobile phones happily accept any client provisioning message without message authentication code. Huawei, LG, and Sony require the security information, but do accept IMSI signed client provisioning messages. How far does the client provisioning message take the attacker? If attacker through client provisioning message install on your mobile phone its web proxy, he can perform in the middle attack on all your cellular traffic. It means attacker can simply sniff all your network traffic to the server which he controls, and that's it. There are several vendor-specific extensions which allow to set settings for email or directory server or browser and so on. And in this case, attacker can steal your contacts and calendars just by installing its server as a directory synchronization server. Attacker can read your emails just by installing its email server. Attacker can read your MMS and even change home page in your browser. So now it's time to show some of this in practice. And so, as was mentioned, Samsung full with the specification which says that authentication is optional, and Samsung Galaxy smartphones allows any client provision message without any authentication. And on the upside, the implementation lists exact what settings are going to be installed, but would user understand any of these technical details? Would your parents know what an IPN proxy IP is and what its value should normally be here? So I think that no. Now we're going to show a simple demo video where we send a provisioning message from my laptop and to Samsung S8 and redirecting all network traffic from the telephone to our Amazon server.
Right, so in this video you see the attacker's computer desktop on the left and the victim's mobile phone screen on the right. So what the attacker does is he runs the Python script providing just the phone number of the victim. Then he opens his favorite tool for man-in-the-middle attacks. So we used Beef control panel, that's a standard tool in Kali Linux distribution. In the meantime, the victim has received the message. He opens it to see what's inside. He sees all the details, including the proxy IP of an Amazon web server. He installs the settings. And now he's going to open his browser and try to go to MIT web page. And when we see his request in our Beef control panel, we would be able to redirect him to something else instead. So we're using social engineering tools, and that's a pretty theft, and we're going to push him a fake Facebook login page. So when he puts in his email and password, we're gonna intercept that and basically steal his Facebook credentials. So that's quite neat. Yeah, there we have it.
Okay. Okay. Three these vendors, Huawei, LG, and Sony, require the client provisioning message to be authenticated. And as was explained before, the authentication key is IMSI. As you can see on these three screenshots, none of these vendors provide any details about settings which have been installed. And so who is the message from? What is going to be changed and why? Is there anything to worry about before you press install buttons? So the answer is not and nothing. And now we're going to show a second video, the similar video with we attacking LG smartphone, providing IMSI which we steal before. This one. Oh, okay.
Right, so the only major difference here is that the attacker passes IMSI number as well as the phone number when he runs the attack, and opens the Beef control panel same as before. Now the victim received the message. It only has install button, not even an option to cancel. When he's accepted the settings, he navigates to MIT website same as before. And this time we're going to mount a different kind of man-in-the-middle attack. Right, we see his request. Still do social engineering, but now we push a fake Google account login page. So he sees the login page, unsuspectingly puts in his username and password, and this time we are stealing his Gmail credentials.
Yeah. So why is the client provisioning the perfect phishing attack? It can target any mobile phone starting from very first Android versions and even pre-Android phones. And Open Mobile Alliance specification provides no way to verify the origin of the client provisioning, apart from IMSI authentication, which took little time to overcome. An attacker doesn't need any software, any sophisticated software or hardware to perform this attack, and it can target any mobile phone or as part of the large-scale phishing campaign or with a narrowly targeted attack. Finally, the recipient of the client provisioning has very little visibility and control over the settings which are going to be configured, and would probably not understand the implications. To mitigate this attack vector, we recommend the following. First of all, mobile network operators should just drop any client provisioning messages from unauthorized parties, because regular mobile user never have a valid reason to send client provisioning message, and actually it's this just only the effective mitigation, and we were surprised that it had not been implemented during the decade that the client provisioning protocol is in use. There are a few more possible mitigations, but less effective. For example, the smartphone vendors can discontinue support of client provisioning protocol. It should be noted that client provisioning protocol, it's not a core Android feature. You can't find this in vanilla source of Android. It's just a vendor-specific implementation. So it could be discontinued to use. And alternatively, the smartphone vendors could improve user interface to give users more control and more visibility over the installed settings, and as well as educate them about possible mitigations. Finally, Open Mobile Alliance should to revise this specification and devise more secure protocol for client provisioning, which allows verification of the origin of the suggested settings. We, in March, we reported our findings to the vendors and to Open Mobile Alliance, and Samsung and LG reacted quickly and patched these issues. And these two patches, you can see it here. Huawei acknowledged the issue and are working on a fix for the UI for their new models of their phones. Sony, on the contrary, did not acknowledge this issue and stated that their mobile phones full of this specification by Open Mobile Alliance, and still not convinced that there is a problem which should to be fixed. And Open Mobile Alliance itself opened highly priority ticket for this issue, but the specification updating is not to be expected in the short term. So thank you for your attention. This is details of our coordinates, of our contacts, and you are welcome with questions.
So thank you. Can we proceed with the question answers from the audience?
So first of all, thanks for the talk. Second, it feels to me like this is a real issue for the mobile operator, and I was wondering if you had tested this issue with different operators in Israel or somewhere else in the world, because I'm wondering if some of them take actions against it.
We only tested it with 2 Israeli operators. We didn't test it abroad.
So are there plans to test it abroad?
Yes. At some point.
Any volunteers?
There you go. As you can see, and so LG and Samsung reacted really quickly. So it's problem in Asia, as we know. So,
Any more questions? Yeah, the lady there.
Thank you very much for the session. So my question is, you mentioned all the vendors for Android. What I don't see here is the Pixel phone from Google, and Pixel is actually outsourced to, they have changed vendors. I don't know who's the latest. So I'd like you to tell me whether this has been patched or not patched. The other thing is about the IMSI. So it is very interesting that one can get hold of the entire world's mobile phone number quite easily, because as long as you know the IMSI, you can enter it and generate all the mobile phones if you want to attack everybody or spam or whatever. So how does the mobile operator prevent this from happening? Thank you.
So for the first question, the Google Pixel just doesn't support this protocol. And as we mentioned earlier, it's a vendor extension that some of the vendors chose to implement. Some others chose not to implement. So, for example, Apple is not a member of OMA and never has been, and they are doing all their own protocols and not relying on any of these protocols. And for the second part, yes, in the same manner as you can spam the entire internet just by picking random IP numbers, in very similar manner you can spam all phones in the world. Like, there is no way to prevent this, because when a network operator sees an incoming message, he has no way to validate whether it's coming from a good person or an attacker.
Okay, I think there's one gentleman there with red shirt. Yep.
So you guys, what hardware did you use to test out these attacks, and where can you get this hardware? I thought it was like a $10 dongle or something.
Yeah, it's exactly this.
So you can just order it online?
I think we just bought it in a corner shop.
Oh, okay.
Not anything sophisticated at all.
Thanks.
Any more questions from the floor? If not, maybe we can go to the first question on the most upvote. Oh, there are 2 with the highest number of votes. Maybe we can answer both of them.
How do you sniff inject SMS mobile connection packets if you want to do such research? No. We just wrote a simple application that subscribes to all the incoming packets and basically dumps it into Logcat. So yeah, all you need is a debugging connection to your Android phone.
And the next one, will you make Python script available?
No, we will not. We're a defense company, and we're not encouraging such attacks.
Okay. Maybe we can answer this third one as well. Then I have a question.
Sure. Forensic record of where they... It probably would have the source number stored somewhere, but we have no idea how to extract it. Like the phone itself doesn't show the origin number at all. Like if it writes some logs with a dump of the incoming message, such as our debug application, then it would be possible. If it doesn't write such logs, then no.
Okay. Yes.
So, sorry if I'm coming late. I had to pack the baggages. I lost your talk,
No
but
problem.
I know the topic and I have a question.
Yes.
Me and my wife, we do security, and we fight the bad guys and governments. And we keep on to receive OTA at, everything that you explained, I think, on 2 phones on which we used to have installed our personal SIM cards, but it's removed. And even when it's in airplane mode, but it's obviously connected to Wi-Fi. What's your explanation of this?
I don't know how to explain it.
Would you like to cooperate, understanding who is trying to kick our ass and we kick back together the ass of them? Because I would like.
We can try to see, but yeah, it's probably nothing to do with this attack because it has nothing to do with Wi-Fi. It's all about the mobile internet.
This is cellular. Only cellular.
Let's talk more about this because I'm not so 100% sure of your answer.
Okay.
So are you going to leave or you're staying?
Staying.
Okay. Talk to you later. Thank you.
All right.
Actually, I have a similar question to this gentleman. I have two questions now. Yeah. So basically, my understanding that this is all about cellular. This is cellular based. So it's about you hijacking SMS,
exactly.
right? Which you don't have in Wi-Fi, right? So my question then is, if that's true, what I just said, if that my understanding is correct, then my question is, do you see this continuing in 5G networks?
As long as the protocols don't change, because in this 4-layer stack which we showed on one of the earlier slides, it's only the bare layer which depends on the actual wireless technology. But all the upper level protocols remain unchanged. So this is, for example, the reason why this hack attacks to all phones starting from the old Nokia smartphones.
Yes. So I can understand this working where you use SMS for configuration settings,
yes.
right? So question then is, are you aware of different ways to do configuration settings in 4G and 5G networks, which would bypass this use of SMS and therefore not have this issue?
No, we're not aware of such developments.
Okay, great. And I think I actually like that next question. Does mobile device management help mitigate this vulnerability?
Currently, as we know, no. Actually, it's enough. So, as we explained, there are several possible attacks here. Man in the middle. Stealing emails, stealing MMS, and so on. And man in the middle, of course. So it's enough that any MDM or any other application, it's enough to send, for example, request to his server and check IP of received connection. So there is a simple way to understand that there is proxy server. So in this way, yes, MDM, it's possible, it's simple to understand that there is a man in the middle, okay, for cellular network. But what about emails and MMS and so on? Yes, it's possible, but it's too difficult, I think, because in this case you need to analyze traffic. But if you simple application on an Android phone, you haven't access to traffic. In case of MDM, if you open into your own VPN, as in this case maybe, you need to just to parse all traffic and understand IMAP protocol, for example, or POP3 and SMTP to understand that there is some proxy. So it's possible, but it's too difficult.
Okay, thank you. Before I go back to the questions on Slido, any other questions from the floor? Any more questions?
It will take time. I have to finish it back, but I'll talk to you after because I got an idea of
okay.
why is happening such a wording. It's a mix of the two things.
Any other questions from the floor? No? Would you like to answer the next upvoted question? What is the cost involved in executing the attack?
Well, for sending the client provision into one phone, you pay for 2 SMS messages. So that's essentially zero if you're on an unlimited SMS plan as we are. Like, if you're going to spam 1,000 phones, then you probably would need a more expensive plan. But yes, it's basically the cost of SMS message itself.
So it's really dangerous. It's any children can send a lot of message to your mobile phone, and I'm sure that you will press install because it's a regular message, and sometimes you haven't cancel button at all. So.
Okay. Any questions from the floor? All right. If not, then actually, I wanted to check with the gentleman at the back. Do we have the name of the highest voted question, upvoted question? I didn't. I don't remember that one. Are they gone? Disappeared? Or maybe, gentlemen, can you choose your favorite question from the audience? Oh, yes, this one, the one with 5 votes. KH. Who's KH? Yes, here you go. Okay. Okay, and the next one's anonymous. So, gentlemen, would you like to pick your favorite questions from the audience?
Our favorite was the two questions from the lady in the back.
Yeah, thank you, lady.
Okay. Yeah. All right. I think we still have quite a bit of time. You're welcome. You want to answer two more questions, and then we can call it a close. Yeah.
So the requirements of user input. You would still need user input, but we know that many malware applications receive the accessibility permissions which allow them to simulate user input. So then, for example, such an application can forge a client provision message to the phone itself, and this way hijack all the user's traffic. So basically, it would still need user input, but it can be simulated user input.
Okay. All right. With that, I would like to thank you for your presentation and for answering the questions. Ladies and gentlemen, please give a round of applause to our speakers from Checkpoint.